Okay, so what I'm going to show you now is the tech stack and especially the Go code we are using at Domonda. In general, there's no rocket science involved here. It's more like architecture and the way we go about solving the usual things you have to do. Yeah, we're using Go for server and command line tools. We're using Postgres and are very happy with PostgreSQL. Who knows that here? I guess so, nobody. So basically what that is, it's a GraphQL API layer for Postgres. So basically you can create a GraphQL API from a schema where you can query your schema, and you can also do mutations. Those mutations are SQL functions that are called. You can implement them however you want. And yeah, basically it really gives you an API for your application out of the box if you have a matching schema for that. And by using different schemas and views, you can also do things like different APIs. So if you have an external API for your customers that's somehow different, you create another schema with views on your internal structures, and basically you get an API free out of the box. So we've been really happy with that. That's implemented in Node. It introspects and uses all kinds of Postgres wizardry to make that happen, but it really worked out of the box and really good. We have a proprietary document database with versioning. So as I said, we are into accounting, and the most important thing here is to never lose anything and always be able to prove that this document has been delivered that way, has been changed, and all this stuff. And for that, we created our own document database that's completely file-based and has things like versioning and checking out, checking in, and so on. I'll get into that later. For the front end, we are using the usual React Redux stack and GitHub, like many for source code and also for deployment. So how we go at Domonda, how do we structure those things? So we have a single repo in GitHub, and we have a monolith first and serverless later, meaning we always start with the monolith. Everything is much easier that way, and when we see we can split something off, do something on AWS Lambda or something like that, we do that. We don't go for microservices first and build a lot of microservices, only when we see there's a benefit from going away from the monolith. May also change when we have a bigger team, but for a really small team, a monolith and a single repo brings the most productivity. We are very strongly following the UNIX philosophy, so everything is a file and command line tools. That's basically all we are using, or basically everything you can do at Domonda with our data, you can basically do with files and command line tools. And Postgres is basically for us just an indexed cache for querying, but everything is also available as file, and we can recreate our complete database from files. Also very important for backup reasons, never lose any financial documents. So about our own document database, it's completely file-based. It can run on S3, and we don't rely on any features like file dates. It's just the content and the naming of the whole structure. And we have versioning, we have checking out, working on some files, checking them in again, which is locking. So one client is doing something with the document, of course, nobody else should be doing something else to the document at the same time. And that's basically a lot of functionality that you get from version control systems. So why we are not just using Git for something like that? Well, we have lots of data, and performance is always an issue here. And if we use some version control system, we can't use storage like AWS 3 and Glacier, which really helps together, especially with things like Lambda. And we have our own special requirements. So by developing our own thing, we have complete control over what's going on. And that has paid off so far. There have been lots of things going wrong in development, but we never lost any data, and we have the complete history of everything. And yeah, that has paid off so far. So yeah, the nitty-gritty stuff you always have to do, logging. I mean, it's here more a philosophy thing. Basically, you can say every developer develops his own logging system once in his life, or twice or three times. Why not use whatever logging library is your favorite library, because it can do everything. It may be that there are some other logging systems in the background, but what we're dealing here is more like the philosophy, what we want to log. You know, there are different things like 100,000 log levels and different kinds of logging messages and warnings and errors and all this stuff. And how you want to handle that is basically a philosophy and something you have to decide for yourself. And we are going with a very simple approach. Like everything else in Go, make it as simple as possible, not simpler. So basically, we have a logger which is an interface with three methods. We have printf, which prints log messages. We have debugf, which outputs debug output, and that's something you're just using for development. And then we have unresolved error. And it's especially on purpose, this long name, this cumbersome name, because in Go, you don't throw panics, you don't have exceptions. You want to return all errors, and all those errors bubble up, and even at the highest level, you have some way to handle those errors. And the only case where you have an error that isn't handled, because, for instance, you had another error first and you can't continue, and then an error is created because of the error before, and you have no way out, that is when you would use this unresolved error. Everything else is just a printf log message, and you decide yourself what's in the log message, and the format of the log message decides what you're logging and if that's an error or not. So usually you also log errors with the normal printf, and only if you don't find any way out of your state, basically you use the unresolved error. And that's basically how this is set up. So what we have is in our repository, we have a Go directory where all the packages we are using from the Go server and the Go command line tool are in there, and we have one single logger package, and this logger package is used by all other packages for logging, and the whole configuration is done here. So basically what you don't have a mouse? What you can see here is basically we log to the command line with some callers, and we can set a log file if we want to. And every package then has its own log variable. So for logging, we are not using this logger package directly. We create a log variable, which is these logging vars here, which just references other variables that's used for logging. The reason for that is if you have all those dependencies, everything depends on this logger package and so on. You have the problems of initialization and in which order are things initialized and so on. And basically by referencing just other variables with the address operator, like you can see here, the logger var is the real logger we are using from the logger package. And then we also are referencing the debug variable, which is defined in the line above. That means that those can be changed at any time, and we don't depend on the order of initialization. And if you want to debug or get debug messages from a package, you change the debug variable in that package. Error handling in general, so we said we always want to return errors, never panic. And one pattern we are using is that we are wrapping errors to get better call stack error information. So for that we're using this GitHub BKG errors package, which I can highly recommend. It's very simple. All you do here is just wrapping some errors with a call stack and some metadata, and that helps you in debugging if you print out that message. And what you can see here is the defer call. If you're not that familiar with Go, defer makes this call wrap error result run after the whole function has been executed, and it will be called in any case, even if a panic occurs. And if you're using result variables like error here, this error will always hold the result of that function. So even if you define another error and basically override the original error, whatever will be returned from that result will be available in this defer wrap result error function. And what we're using here is, again, we're taking the address of that result variable. That way we can look at the variable, and that's basically the function that we're deferring here. So if the pointer points to a nil error, we don't have anything to do. But if there is some error, then we create a nice error message. We log the whole thing, and we also wrap in the last line the original error with all this metadata that we've created. And that way, basically, if you crash and get a call stack, you see what functions have been called with what arguments. So another convention for defining errors, usually you have something that describes this error. So this error here, document not found, we're using UUIDs for document IDs, and basically we can define this error just as an basically extension of that type by adding an error method that creates the error message. And one convention that we are using is that if we create such an error, we also create an isErrorName function that checks if an error is of that type. So usually if you return errors in Go, if you want to do some error handling, you have to check what type of error are you using. And because we're using this errors package that does wrapping of errors, you don't get the original error. And in that case, if you just check for the type, you wouldn't get the right type. And basically what this errors package has here to resolve that is the errors cause function. But something that happens all the time is that we forget to use this error cause when we check for the error type. So the convention is to always use this is error whatever type function, because it always has that in it. And yeah, that was more the mundane stuff. Now for the interesting things. So as I said, we have this UNIX philosophy where everything is files and commands. And basically in an application, a command is a function. And what we are doing is we are wrapping functions as commands. So to do that, what do you need for a command to run then? You need the arguments and you need to do something with the results. Here's an example for this batch overview text function, which returns just some overview plain text that we use in different places, and we are wrapping that with a CLI dispatcher where this function can be called as a command from our command line tool, but the same function can also be wrapped, or the same command can be wrapped as a server route for Gorilla Max, the server framework. And you can see that we are just adding this basically few lines of code, and we have the same function available from the command line and also as plain text response with a server route. So that's basically how the command line tool looks like internally. So we have this string args dispatcher, which takes string arguments when you call the command line tool and converts them to whatever types the arguments of those commands take. So it's a standard built-in conversion for the usual stuff. You have integers, you have UUIDs. If you have structs, then it's automatically using JSON to convert to and from that from a string. And basically, you can wrap any Go function as a command. And then here this struct flag load file if it exists and pass command line. It's fancy for basically look if there's a config file, use that, create, initialize our configuration with that. And you can also change this configuration with command line flags that override whatever you have in your configuration file. And what's returned from that function is the arguments that don't have any flags in them, and they are then used to dispatch a command, which is here this dispatch combined. And that basically runs the command, and if there was no error, we have still some cleanup work like we have here. The thumbnails work until work are finished. That's code like we use it. Here's something more complex. Here we have a function with one argument, the get table row with primary key. So we're using UUIDs for everything. And what we have here is a function where you can just look up any UUID and it will find whatever table is using that as primary key and return you the data, which is quite handy if you're having a lot of UUIDs in your logs and you don't know what this is. You can just fire up the command line tool and it returns you what table, what content that UUID referenced. And what you can see here is this variable, the get table row with primary key args. This struct defines the arguments for this command. So it has this command args_def that's basically inheriting the methods you need to handle that thing as a command argument description. And then every field in that struct describes one command argument, and we're using reflection to get the type, and also, as you can see at the tags in the end, the ID lowercase, we want to use the name for the command argument because we are forced to use uppercase for exported struct fields, and so we have the name and also some description that will also be used when printing help information for that command. And basically, for commands, we always have those pairs of this args_def variable and the function itself. And below that, again, you can see how this command is added to a command line dispatcher or to a router that handles that same command as a web server. I can show you a little bit more from our code base here. So basically what we have is this Domonda CLI. That's the thing that can do everything basically that we can do on data. We have quite a lot of commands here, and if we call that, looks like that. Oh, okay, can't increase the size, but here are all commands that you can do to our Domonda data, and then also the general configuration flags that we use basically to configure everything for all tools to work. And for our doc server, so I said we have this PostgreSQL API for Postgres data, and for accessing the document database, we have our doc server, which is basically normal REST services. And just to show you how that looks like, so what we have here is this server run function with Gorilla MOOCs and creating lots of routes, and basically they are all wrapping just functions. So this doc database create restructure group is a normal function. It receives this struct. This struct is automatically converted between JSON. So if you call this route with JSON input data, it will convert it and call this function. If there's an error returned, this error will automatically be converted to 500 internal server error. If it's not a special error, if it's a special error like a 404 error, then it will use that for the response. And if we go back to the route, so what we see here is this is the route, and we have this request body argument in that's taken and converted as the in argument for the command, and it calls that function with that argument's definition, and the result, when it's not an error, will be returned as a JSON response. And basically the same function is available from the command line. Yeah, that's it. So this is again an overview of those packages that do this command magic and the errors and the Gorilla MOOCs package we're using. Questions?